All right, hi, I'm Heather Brown, and this is,
Janine Shepard.
and today we will be joined with Julie Brunson, who is going to talk us through some statistics. Um, Welcome to IL MathCom. As always, our goal here is to spread the joy and wonder of mathematics, and today that spreads to statistics. And apparently, as I just told some of our guests, we are in April. April is Statistics Awareness Month. How cool is that? So, if you have any questions, please let us know throughout. I'm going to go ahead and put some links into the chat. Here's where we're going to put the forum. If you need to find the chat, at the bottom, you can scroll to the bottom of the page, there's a chat window. And there's our forum. If you have questions, you can write them in the chat or you can ask them out loud. If you didn't hear about this from our listserv, you can join our listserv there. And if you want to comment or tweet about IL MathCom, you can do that using our Twitter and Facebook page. So without further ado, I will go ahead and tell you that Julie Brunson has been amazingly helpful to us in Illinois. She has done instrumental work at creating and working with the IL Stats webpage that we have. We have it linked to I should put that link in there right now. And she has taught several years at Lyons Township, and she's gracing us again with her statistical knowledge. So go ahead, Julie.
Hi, it's nice to see all of you. And I'm going to share my screen if I can. Here I thought I was ready to go, Heather, and I cannot find here we go. And slowly but surely, hopefully this will come up. There we go. And thank you all for joining us here today. What we're going to try to focus on is just a little bit of information about the middle school statistics and probability standards that should be taught in 6th, 7th, and 8th grade. And along the way, we're a small informal group, so please jump in if you have questions. Let me know or let Heather know. But one of the things I'd like to ask you to see if you can have is if everyone would have some paper, just some basic 8x11 white paper, maybe a pen or pencil, and I use sticky notes. What we're going to be doing is making a couple of dot plots like this so that you can share. I don't know if you can kind of look at the corner where Julie Brunson shows up, and then you can see my dot plot. Can everyone see that from the little side screen there? But it's basically a dot plot where the number line is scaled 0 to 9 or 0 to 10. I made the numbers about 1 inch apart going across the bottom. And then I have little pieces of sticky note that I've cut into 1 inch squares that I'm using as my dots. But if you don't have Post-it notes, you can feel free to use a pencil, a pen, or something to mark on it to make it easier. So we're going to kind of dive in. My goal today is to talk a little bit about an activity that I call family size that I got from Christine Franklin, who's with the American Statistical Association. And it's a really good way to learn how to cover MAD, the mean absolute deviation. So I wanted to show you that because it's probably the best way I've seen to introduce it and really have kids get great conceptual understanding. We may slide a little bit of work in there about dot plots afterwards to see if people have questions. But the main thing I want to do with going on to box plots is to make sure that people are ready for those 7th grade standards where we informally make inferences by comparing two distributions. And then I want to wrap up a little bit with talking about curriculum and where do you teach the stats unit in 6th, 7th, and 8th grade, and do people have the curricular resources they need and feel comfortable with that? On this screen, what I did is I sat down and thought, I'm going to look at all the middle school and high school statistics standards, statistics and probability standards, and see how they're connected. So what you end up with is this that looks like a spider web almost. But the thing that I wanted you to really get from this is that this column here is 6th grade, this column is 7th grade, have 8th grade down here mainly because it's a little bit separate. Sorry, let me go back to that screen. And Algebra 1, Math 1 would go down the whole middle column. Algebra 2, Math 3 comes down this column. But notice that how connected all of these topics are. There's a big association with what you cover in 1 grade and how it is also going to be needed as it's built on in following grades. So in 6th grade, we start off with a gentle introduction to statistics. What is a statistical question? But the main focus is on shape, center, and spread. And those same ideas come back up in 7th grade, but where we compare two distributions. And they come again in Algebra 1 and are certainly needed as you move into Algebra 2 or Math 3. In 7th grade, besides comparing shape, center, and spread of two distributions, you also talk about random sampling and you start probability. That probability is going to be needed as students move into 8th grade, where they do two-way frequency tables, which continue on to Algebra 1, Math 1, and on into Algebra 2, Math 3. So the main thing is I just wanted you to see that there's a real connection, and if you or your staff at schools are skipping the standards or just feel like you're pressed for time and so it's the easiest thing to throw out, that actually can have some impact on students as they continue on through middle school and into high school. And we want to try to make sure that students are getting that whole coverage of the statistics and probability standards. Anytime you talk about statistics and you have a distribution, the main thing you want to make sure you do is talk about the shape, center, and spread in context of the data you use. And the other thing I would highly recommend is try to use real life data, or at least data about your students in your class, rather than making up data sets. And I don't know if you guys had this experience, but I can remember sitting down in high school and in college and doing stats problems where it was just a list of numbers that had no meaning, and then you just sat there and crunched out using formulas to come up with means and standard deviation, and it didn't have a lot of significance. Really, the emphasis here is less on the number crunching and more on learning what it means and getting the context of what we've learned from things like mean, median, and the MAD. So we're going to go on and look at family size. And family size, you can use this activity if you want to talk about mean as a balance point. If you're comparing mean and median, and when is the mean greater than the median. And also for absolute MAD, the absolute deviation. And again, I got this particular activity from Christine Franklin, who is the ASA, American Statistical Association, K-12 ambassador. So this is the point in time when I'd like to ask you to go ahead and take out a piece of paper. But what we're going to look at while you have that is, here I have 9 families, or I should say I have 3 samples, each of 9 families. And for each of these 3 groups, people were asked to report the size of their family. How many people were in their family? So figure 1 shows one group of 9 families, figure 2 a second group, and figure 3 a third group. And if you focus on figure 1 right now, what I'd like to do is say, well, I'm supposed to talk about the center, so we could find the mean of this. And do you guys want to look there quickly, and can you quickly calculate the mean? And we're going to take a page out of one of Heather's presentations that she did a little while back. Once you have the mean, if you can put your hand on your chest, put your thumb up if you have an answer. If you think you know more than one way to get the mean, you can hold out fingers to indicate that. But does anyone have the mean for figure 1? Heather, you got it?
I think it's close to 6 because I was trying to do the balance rather than the calculation.
All right. And so when you're saying you're trying to do the balance, what are you looking at?
I am trying to think about where guess the fulcrum would be where it, to get to 6, 7 has to move over 1, and 8 has to move over 2, and 9 has to move over 3.
Okay.
So that would be 1, 2, 3, 4, 5, 8. And on the other side, I'd have 2 1s, a 2, and a 4. So it's also 8. So it's exactly 6. It's not close to 6.
Yeah, and that's a great way to do it. If you just think of mean as the balance point and try to figure out which number here would you be equidistant from. So if you look at 9, you've come out 3, as Heather said, and the 8s are 2 away. You certainly could just add up all the numbers, add a 2, a 4, a 5, a 5, and so on, and then divide by 9 and get the mean as well. The other thing is, did you notice if you ignore the 2, the rest of the distribution is very symmetrical? And when you have a symmetrical distribution, both the mean and the median are right in the middle. So if I could get rid of the 2, the mean and the median would fall at about 6.5. Mm-hmm. As soon as I add an outlier, then you find that things are going to shift a little bit towards the outlier, which does actually pull it down to 6. So the mean for that group is 6. Now, figure 2, hopefully, is a little quicker to come up with the mean. What is the mean for figure 2? And again, you can put your thumbs up when you know it. Amber, what do you got? Yeah, it's a 6. And basically, every value there is 6, so the mean comes out to be 6. Figure 3, if you think of Heather's strategy of the mean as a balance point, that might give you kind of a hint as to how to quickly get this. What does the center of that look like? Kathy, you got any ideas? You can unmute yourself if you'd like.
I don't think I can see them on. Okay.
Can you see the numbers here in the graph?
What was the question again?
What do you think the mean of figure 3 is?
6.
Yeah, it also is 6. And this one in particular, using Heather's idea of mean as the balance point, notice that 2 and 10 are equally balanced. 1 is 4 above the 6, 1 is 4 below. 3 and 9 balanced, 8 and 4 balanced. So the mean would be 6 as the balance point. But even though all 3 of these distributions have the exact same mean, notice if you didn't see the distributions and I said, hey, you know, I took 3 different samples of families. Each sample had 9 families, and I asked the family size, and all of them came out to have a mean of 6. Without the picture, you still really don't get an indication of just how different those 3 samples were. That's where the shape and the spread come in and become very important. Now, when we think of mean or median, you'll often see, and this is true even on some of the PARCC questions, that's a mean or median is considered the typical value. So if I looked at any one of these 3 groups, I would say a typical family size is 6 people. Sometimes they talk about consistency, and consistency has to do more with spread. So if you look at these 3 family sizes, which of the figures shows the family, the group with that is most consistent? Thanks, Janine. Yep, it's 2. So right here, this is all the same. So these 2 have more variability, much more spread. This has actually 0 variability, 0 spread. All right, so going on to family size, what I'm going to do is I'm going to either use my piece of paper here. So if you can get a piece of paper and just number it 0 through 10 and make a nice number line. I'm using little sticky notes, but you can certainly use just a pen or a pencil as scratch work. And what I'm also going to do is stop for a minute. I'm going to pull up something called Fathom Statistical Software. And can you all see that on your screen right now?
We are still seeing the PowerPoint.
Okay, let me see.
So when you shared your screen, you might have shared a specific.
Yeah, let me see if I've got that. How's that?
There you go. Yep.
Okay. on this particular slide, I'm going to do family sizes still just so that it has a context, but I'm going to drop it down so that I only have 2 people in my group. So I took a sample of only 2 families, and one family had 5 people and one family had 7 people. Now, notice that if I did the mean or the center of this, it falls right at 6. And in fact, here in Fathom, I can actually put something down for that. I can actually say, hey, I'm going to put in a line for a mean. And so we can see where the center actually falls. But what I'm going to start talking about now is the variability, the MAD. And when you do MAD, it's really about what is the average distance we expect data to be from the mean. Because most of the time, when we take a sample, we don't really think everyone is going to give the same answer. We don't expect all of our families to be size 6. We expect some variability. And so the MAD tells us, typically on average, how far from the center do we expect the different family sizes to be. And so to begin with, if you just look here, do you notice that the 5 is 1 below and the 6 is 1, or the 7 is 1 above the mean? When you find MAD, you take the absolute value of those 2 distances, or the distance from the mean, and I have a 1 and a 1, and together you get 2, and I only have 2 data points, so 2 divided by 2 is 1. That means the MAD for this is 1. An average distance from the mean would be 1. And that seems to make sense because of this. But now what I want you to think about is, what if you had a family that had 3 people in the family, and the numbers were supposed to still have a center of 6, but this time we want to try to have something bigger, a bigger mean. Now, before I go on to that, let me just back up one step. What would I have to do to these 2 families to make it so that I still had a mean of 6, but I had a MAD of 2? The average distance from the mean was a 2. Any suggestions? So I have Janine and Heather both showing their thumbs going out. How far out, though? Yeah, if you just basically move them 2 out. So I'm going to come here and just type an 8 so that moves out to 8. And this one, I'll move it down to a 4. And you can see that you end up with that a MAD of 2. And down here, I've actually created a little table that I'll pull back up onto the screen, where I keep track of the mean. That's the top number here, and I have my MAD down here. So that's 2. What I'd like you to do on your own paper and your dot plot is, suppose now that I want to have a MAD that is still 2 and a mean that is still 6, but I wanted 3 families. How could I arrange on the number line 3 values? What would the numbers in the family have to be so that I could end up with a MAD of 2 and a mean of 6 and have 3 families? And try playing with those numbers for a minute. Does anyone have any suggestions?
I'm still thinking.
Okay, I'll give you a little more wait time then.
You want the MAD to be what?
I want the MAD still to be 2. So the mean absolute deviation should still be 2, and the mean should still be a 6, but I want to have a total of 3 families, not 2 families. Okay, so Heather has an answer. Kathy, how are you doing with this?
Oh, no, I don't have an answer. I thought I did.
Well, what did you try, Heather?
Well, I was trying to find something that, oh, no. Oh, yeah, I do.
Okay.
No, I don't. So I was trying to make it add up to 18, and I was just trying to put 2 of them below 6 and 1 of them above 6.
Okay.
So, but I had 2 5s and an 8 didn't work, so 2 4.
So you wanted to try a 2, and then a 4 and an 8?
Yeah, but that doesn't add up to the right number.
Yeah, and the mean now has shifted.
Right, it needs to add up to 18. That's what I'm saying.
Yeah.
Oh, couldn't you leave 1 at 6?
You could, which one do you want to leave at 6?
And then you'd have to, so you would do 3, 6, and 9?
All right, so 3, 6, 9. And this has a deviation of how much?
None.
Yeah, none. It's 0. And the 9 is 3 away. And the 3 is 3 away. So we have 3 plus 0 plus 3 is 6 divided by 3 values gives us a mat of 2. So that's a great one. Is that the only one? Any ideas of any other choices?
Ooh, I got another one.
Okay.
3, 5. Nope, I keep doing 16 instead of 18. Never mind. I don't have another one right.
Okay.
I don't know why I keep adding to 16.
Does it work if I try 4, 8, and 8?
That's not 6.
Yeah, so my mean is not helping me at all. What if I could move one of these points down? And notice in Fathom, I can actually grab a point and drag it down. The only problem is that I'm not good at being precise. So I'm going to come here still and just type this and say, yeah, move this to 7. Notice that's still not 6. So is there any other possibility that I can have? What if I wanted the mean to be 6? How far away is that 4?
Move it down 1.
What about 2, 6, and 8?
Okay, 2, 6, and 8.
No, that doesn't. No.
Yeah, it did kind of shift
Too far.
that a little bit. What if I tried 4, 7, and sorry, I'm getting this all in the wrong column there. 4, 7, 9. Still doesn't work. The main thing is somehow or another you're trying to balance. So if we go back to this idea that 4 and 8, sorry, my enter is not hitting. There we go. I'm going to clear this guy out.
4, 6, and 8. Oh.
Notice that this is 2 away. How can I put 2 on this side and have the total distance, the sum of the deviations on this side also be 2?
Wait, repeat that? How can you do what?
Well, in order for this to be the mean, I could have this be 2 away. And then what would I have, where would I have to put numbers so that they ended up 2 away as well?
Like if you had 2 at 7?
1 at 7 and 1 at 9.
Okay, well, if I do 2 at 7, I still have my mean of 6. Is this a MAD of 2? Yeah, so this is 1 plus 1, that'd be 2. 2 that way would be 4. 4 divided by 3 would be 1 1/3. Maybe I should pull that table back up on the screen so we can see. Somehow or another, what I need is a set other numbers, and this makes a great problem-solving task for kids trying to sit here and play around with the numbers to see if they can generate something that works. You could try 3, 5, and 8. And notice you're still not centered, but it's something where you can actually let kids toy around with and say, you know, is that 3, 6, and 9 the only combination, or is there a way to balance it and still have it? It makes for a really good thinking problem. But as you can see, it's challenging to try to see if you can come up with other numbers. So it might be something that you give to students if they seem like they're really getting the idea, and otherwise maybe you save it. Then try something like this. You may want to, as you kind of gently introduce them, say, hey, let's keep a mean of 6, but I want to have the spread be as big as possible. I want a MAD that is bigger than 2. How can I have 6 families, still have a center at 6, a mean of 6, but I want the spread to be really large, as big as I maybe can possibly make it? Where would you put those families? Heather, got an idea?
I would do 0, 0, and 36.
Well, what kind of family would have 0 people in it?
Dang. 1, 1, and 34. Is that a
Okay.
family? You have to define what a family is. A single
You're
person?
right. That's a real good point.
Maybe 2, 2, and 32.
Okay. And I would have that discussion with kids. You know, can one person be a family, or do you need to at least have 2 people in it? If we go 2, 2, what else did you want, Heather?
32.
So you want to have 32 folks in the family? And
Big
no,
family.
Fathom, I can just pull this down. Sorry, looks like I have a mean of 12 right now. So there we have a mean
Oh,
of,
we needed more people. I'm sorry. You wanted 6 families. So 2, 2, 2, 2, and 26. You asked for 6 families.
so you want all 2s and a 26?
Yeah.
And this is a 6 right here. If you can notice that that's just to the right of that. If you look down here, you can see that the MAD is 6 2/3. But kids could also, you could ask them to help figure that out and let them figure out the different spreads. There's actually a lot of different ways you can do this one, and they'll come up with more answers for this particular one than they would if you, when you actually try to make a very specific MAD. So this is kind of a nice way to juggle it around. I'm going to go back to the PowerPoint, if you don't mind. Sorry, it takes me a minute to get this pulled up. Now, what I do with the students usually is I start off with the MAD, and you can give them all kinds of scenarios. You can give them a certain number of families. You can vary what the mean is. You can simply even say things like, hey, if you had 6 families, how could you arrange them so that the mean was bigger than the median? Remember, the mean is always bigger if you have an outlier or if the distribution is skewed to the right. So you can really test their understanding by having them have to arrange things. Also, if you keep the number of families small, it provides something a little more concrete if you have someone who is struggling to grasp the concept of MAD. Then from there, I go ahead and go back to kind of just that procedural fluency. So I do that typical thing where I make a table and I have size minus mean. I take the absolute value of that and use this to help calculate the MAD. And I show students how they can do it. The nice thing about them learning how to use the table to calculate is that then when you have numbers that aren't quite so pretty and they use decimals, which you should try to do, then they have something that will help them keep track of the numbers. So this is the original family of size 9 that had, or 9 families, and the mean was 6. You list all the data here and then take each of the different family sizes minus the mean to get the deviation, take the absolute value, sum those absolute values. And notice if you sum the deviations, because the mean is a balance point, they sum to 0. But if you sum the absolute value of them, you get a number. And from there, you can divide them by the 9 families and find out the family size. And that's a typical size. So the typical family size is supposed to be 6, but the typical distance from that center, that mean, is 1.8. So almost 2, but not quite. The thing I want you to notice here is if I went out 1.8 family members, do you see how I would capture 4 of the 9 families? And if I think of 1.8 as being pretty close to 2 family members, then I'm actually starting to capture all these numbers coming out to here. And I've captured 7 of the 9 families. So that 1.8 is telling me what that typical distance from the mean I expect to be. And I'll have some people that are a little less than 1.8 or 2 family members, some that are a little more, maybe some that are exactly that distance away. Here's an example of a PARCC question, which I think they do a great job making students think. And this is for grade 6. It came from 2016. And can you all see the question all right? Do you want to read it real quickly to yourselves? And my question is, when you look at the answers there, can you go through the answers and either provide a reason for why something is not a good answer or why something is a good answer? And once you have an idea, if you can put your fist to your chest, if you can explain one of the answers, why it's good or bad, you can put up 1 thumb. If you can explain more, then you can hold up different fingers for the amount of answers you can justify as either being not good or sounds pretty good. Kathy, how are you doing, hon?
Good. I think it's A.
Okay. Well, why are you going with A?
Because if it's the median, trying to think here. The median is the middle number. Yeah, in an odd set of data, the median would be the middle number. Since she tracked it for 7 days, 6 would have to be one of the numbers.
Okay. Yeah, and great explanation. Thanks, Kathy. And then I always ask kids to take the time, to make sure that they look at some of these other answers. Notice the next one. If you go with the idea that Kathy shared, and that is you've got an odd number of data, so the median must sit at that middlemost number, which would be 6 if the median is 6. Then the least amount of water she drank could have been 1 cup. Why is that not a good answer then?
Because the range is 4 from the least to greatest. So
what is the smallest number of cups of water it could be then?
I guess it would be 2.
Yeah, it'd be 2. It's possible still to have a median of 6. For several days she had 6 cups of water, but one of the days she had 2. And the same thing with many of these others is that notice that here the mean being greater than the median, we really actually don't have enough information to make that determination. We'd have to either know that there was an unusually large or small value pulling on that mean, or a larger one to pull it up greater than the median, or we'd have to know that the distribution was skewed. Could be a possibility, but we just don't know that. And for D, if you have 3 cups as the least amount and 9 is the greatest, what's the problem with that answer?
Again, more than 4.
Yeah, you end up with a range that's more than 4. But it's a really nice way to test kids to see that they actually understand the meaning of a median and a range and are applying those concepts, and yet they haven't been asked to actually calculate it. And I think a lot of times we have this tendency to give kids numbers and make them calculate everything as opposed to make them just think and apply the concepts. I know that we may have had some people ask about box plots, and Angelique and Kathy, do you guys want to see anything about box plots? Are you good to go with making box plots? Do you have any questions about them, or can we go on to 7th grade and compare them?
No, I'm good.
And Angelique, I don't know if you can respond.
She's actually called in, so is she, I don't know that she can.
She can talk. Okay.
Yeah.
Well, I hope we're helping. I do want to share one little tidbit about box plots, and it has to do with when you have an odd set of numbers. When you have an odd set of numbers, and here's a list, I've already sorted them in order. There are 9 numbers here. So the minimum is 5, and you know when you do your dot plot, or your box plot, you put the minimum point down. The maximum is 20. The median is right here in the center. Now, here's the thing that becomes questionable, and not everyone recognizes this. When we go to find quartile 1 and quartile 3, quartile 1 is the median of the lower half of the list. Quartile 3 is the median or the center of the upper half of the list. Well, the way our calculators always do it is they say, okay, we've got a median of 14. Don't count that. Since 14 is right in the middle, don't use that. Just use all the numbers less than the median. So 5, 6, 9, and 12. And since it's an even number of numbers, we take the middle 2, average them, and quartile 1 would be 7.5. Same thing happens with the upper half of the list. We take all numbers that are greater than 14, find the median of those by averaging the middle 2. And again, just about all of our calculators will use this method. However, there's a second method that sometimes people use, and that is when they go to find the median, they count the 14 in the lower list, and they would come up with quartile 1 as being 9. And then they again count 14 in the upper list, and then that would make 15 the middle, and that would be quartile 3. And there are software programs that use this second method instead. When I teach using the first method, knowing that the calculators my students use will use that first method. I don't even mention method 2, but I wanted to mention it to you all so that if you ever are using some software and you come up with something that you weren't anticipating, it may well be because the software was designed to use the second method. Both are considered acceptable. And the main thing is I'd pick one method and be consistent with it. And let me just run right through this one. Here we have a distribution for the 2019 Chicago Cubs. I tried to pick something that was timely and current. And at this time of year, the 2019 Chicago Cubs had to pick a 25-man roster. What I did is I went on the baseballreference.com and got the number of years of experience for these 25 men who are playing with the Chicago Cubs and created a box plot with it. And when I did that, it's sometimes useful to kind of know a little bit more information about what these years mean. So for example, there was one player who had 2 years of experience, but those 2 years are counted as 2018 and the current year, 2019. Someone who has 10 years of experience means that they played 9 years in Major League Baseball before 2019, and 2019 is their 10th year. The other thing to know about these years of experience is it doesn't mean that they played for the whole season. If someone last year was called up from the minor leagues for one game in the major leagues, then they are counted as having 1 year of experience in the major leagues. So all they have to do is come up and play a game or two or something, and so that counts. Just so that, you know, because there are some people who shift back and forth. Even Chris Bryant last year when he was injured actually spent some time playing down in the minors when he was recovering before he returned up to the Cubs. What I do with this is I have some data. It has a real life value, and I try to make sure that they know the story behind the data. But then I have students, and this includes my high school students as well. I ask them to write a good paragraph about the shape, center, and spread of this distribution. And I remind them that, when you have a box plot, those quartiles actually mean something. It does divide the data into 25. So we know 25% of our Chicago Cubs, for example, have 10 or fewer years of experience. I'm sorry, 75%. So I can add that up. I know that 25% have more than 10 years or 10 or more years of experience. But when they describe this, I look for them to say something about shape, center, and spread. So I'd look for them to say something like the 2019 Chicago Cubs 25-man roster has a typical value or a center at 7, the median, 7 years of major league experience. The shape of the distribution, well, when you guys look at that, what shape would you call that? Would you say that it looks like it's symmetrical, or would you say that it looks skewed?
It's close. I mean, it's a little skewed, but it's like, those are pretty close to being.
They look kind of close. Kathy, what do you like about it? Do you like skewed or do you like symmetrical? Any thoughts?
I'm going to unmute you. Oh, goodness. There you go.
I said the bottom half is a little bit smaller than the top half, but for the most part, it looks skewed.
Okay. So, and Janine, what do you think? Would you go with skewed or symmetrical?
I'll go team skewed, slightly skewed.
Yeah, and that's the thing. As math teachers, we're so used to being so precise and having there be a very specific exact answer. And quite frankly, when you teach statistics, sometimes you're interpreting things. So you may look at this as Heather does and says, it really is close to symmetrical. Well, let the students know how to equivocate a little bit. Let them say, hey, it's approximately symmetrical, or it's reasonably symmetrical. Or if they like the fact that it looks just a little bit longer on the right side than the left, it's slightly skewed. So they can say it's slightly skewed and just go with that. And then certainly for spread, we can talk about interquartile range, the distance, the interquartile range, if you take the 10 minus the 5, the range of the box here is 5 years of major league experience. Or you can talk about the range from 14 to 2 and subtract that, and that would be 12. What I really want to work with is happens when we look at SB 7 and grade 7, standard 3 and 4 for statistics and probability, where you really are supposed to make inferences by comparing distributions. And this comes from Consumer Reports in June of 1983. They looked at major hot dog brands and had a sample of major hot dog brands that were beef and a sample that were poultry. And the first thing they considered was the sodium content of those. And so what I have here is I have some of the 5-number summary for you on the right side, and I have graphs, box plots of the sodium content for poultry and beef hot dogs for their samples that they took. Now, if you look at that, typically, would you expect a beef hot dog or a poultry hot dog from these samples to have more sodium?
I find hot dogs so unpleasant that I'm having a hard time doing it.
I'm so sorry.
The idea of a chicken hot dog, that just makes it even worse, doesn't it?
I have no idea.
Chicken hot dogs look saltier to me. Yeah.
Why is that? What are you looking at?
if I look at 3 of the numbers on the, I guess 4 of the numbers on the 5 number summary, that it's more than. And the only one that's not is the maximum, which could change based on one data point, could have brought that over. So the minimum is higher. Each of the quartiles 1, 2, and 3 are also higher.
Okay. Yeah, and this one I think is sometimes a little tough to discern, because do you see how much overlap there is between part of these box plots? Students will struggle with this, but the main thing we're looking for is, can they provide justification, just as Heather did, for what they're going to say is their interpretation? Now, when you're asked about typical, you want to make sure that they're talking about the medians, since those are the measures of center. So if we look here, it looks like poultry typically, because of the median of 430 milligrams of sodium, typically has more sodium. Which of the 2 brands are more consistent in their sodium content? In other words, have the least amount of variability or spread? Poultry or beef?
Poultry, but again, it could be, beef isn't that much, except for potentially, like I said, it could just be one that's pulling out. But
yeah,
poultry definitely closer. But their IQR is pretty close to each other.
Yeah. So essentially, would you be confident in saying in general that you would like to conclude that poultry has more sodium than beef, or do you feel a little uncomfortable really saying that?
What was the phrase you used? I'd say normally, usually. How
comfortable would you feel saying that you would conclude that the poultry hot dogs tend to have more sodium? That the difference in sodium is, to you, seems significant? You're uncomfortable making that conclusion?
I was comfortable with it until you said the word significant.
I know there's something about that word significant. So in this case, because there's enough visual overlap right here, you'll have some students who will say, yeah, I really do think poultry has more sodium. And the reason, and they could go back to the reason that Heather gave, which is, if you look right here, 75% of these poultry hot dogs have more sodium than 50% the beef hot dogs. That could be their justification. Other people might look at this and say, you know, there's so much overlap, and this median falls inside the middle 50% of this. This median is just on the edge of the middle 50% here. And so it's tough to feel really confident. Now imagine if I took those 2 box plots and I pulled them way far apart. And the farther away they got from each other and the farther I moved those medians apart, how would your confidence in the significance of the difference grow? Yeah, it would tend to go way up. So don't be surprised sometimes when you have these where there may, again, not be clearly significant information. And some students will grasp onto something, and as long as they're providing great reasoning for it, accept that. That's a great thing. Now, what I'd like to look at next from the same set of data, and by the way, this is actually a data set that was mentioned in the GACE report, which is the report that was done by the American Statistical Association recommending what should be taught for statistics and probability in grades K-12. And the Common Core state standards, all the statistics and probability standards, were really based on the recommendations in that report. And they share this beef and poultry hot dog as an example of a data set that you could look at. This is now about the calories in beef and poultry hot dogs, and I'm going to do this a little bit more formally and mathematically. So you could have a table for the beef hot dogs. This is the number of calories they have, and using that I could find the mean and subtract the mean, take the absolute value of the difference, get the absolute deviation, and come up with the MAD. and I could repeat it again for poultry. However, I'm really big on using technology, so I did this ahead of time using technology, and I already have the mean and MAD for beef and poultry figured out. And this time I have dot plots so that you can compare the distributions for the two dot plots and actually see the different values. And again, now what I want to think about is there a significant difference here? Do I feel like I can conclude that poultry, which has a mean number of calories of 118.8, has, in general, I would anticipate it to have fewer calories than beef hot dogs? Well, one of the standards that you have to teach in 7th grade is talking about compare the distributions by looking at measures of center and comparing how far apart they are using measures of variability. So the mean for the beef hot dogs is shown here at the 156.9. Here's the mean for poultry. And if I look up at the two measures of variability, notice they're not that far off. But if I wanted to see how many measures of this variability of MADs I could get through here, how many MADs would it take to get from one mean to the other? Notice that these two means are about 38 calories apart. If I doubled 18.5, I'd be at 37. So not quite 2 MADs apart. If I doubled the poultry's MAD of 20.3, I'd be at 40. So I'd just probably pass this mean right here. But approximately, they are 2 apart. Usually when you can look at a MAD and say, between these two means, I can get 2 MADs in, that's when we start saying that that difference is significant. And in 7th grade, we're just trying to get them to kind of begin to understand that that's when we start interpreting or inferring, drawing a conclusion, that maybe there is a significant difference between beef hot dogs and poultry hot dogs in terms of calories. Again, I try to work on my students' writing. I constantly try to make sure that I'm integrating this idea of writing, from their ELA standards and including that within the math work. The statistics unit really lends itself to doing this. So they could say something like the center of the distribution for poultry hot dogs is almost 2 MADs, 2 times 18.5 or 2 times 20.3 below the center of the distribution for beef hot dogs. If the two samples of hot dogs are representative samples of beef and poultry hot dogs, then there is evidence that beef hot dogs tend to have fewer calories than beef hot dogs. And here's another part question. This is from 2017. And they're essentially giving two distributions. They're trying to test basically 7SP-B4. And notice how all these answers are really just saying that the number of almonds in these two jars tend to be greater or fewer, and whether they are, which one is more consistent and least consistent. So looking at just the graphs, and notice you're not even supposed to have to calculate anything. The graph seems to have the higher center, the brand X graph or the brand Y graph. Kathy, what do you think? Which would have the highest center, the highest mean or median? Brand X almonds or brand Y almonds?
Brand X.
Okay. So probably somewhere in here we'd look at the center, whereas this one seems to be down maybe just above 55. Which one has more spread?
Brand X.
Brand X. So brand X has greatest spread, brand Y has the least spread. Then if we come down here and we try to look for answers, you're trying to find an answer where they're saying that brand X is the least consistent, brand Y is the most consistent. So if we just start with consistency, this one is saying brand X is more consistent than brand Y. That's not true. This one is saying less consistent than brand Y. So that would be a true one, but then so would D. So we have B and D, but if you look at the answers, which one has brand X having the greater number of almonds? That they tend to be greater.
B.
Yeah, B, answer B. What I'd like to do is just wrap up with some curriculum resources. And Kathy, are you teaching a grade, or are you a coach? Or
I'm a coach at middle school for math and science.
and do you feel that do you have statistics units in place already, or are teachers struggling to know what to teach or finding curricular resources to use?
Teachers struggled, well, the 6th grade teachers, I've noticed, struggle in really knowing what the new standards say, how they're different than, even though they're really not that new, but my teachers tend to stick with just teaching kids mean, median, mode, not really the analyzing that's required. And then 7th grade has trouble just getting to that unit.
Trying to fit it in.
Right.
By getting to it, do you mean getting to it before the assessments, or do you mean getting to it during the school year?
Both, depending on the teacher and the kids they service.
And I have a feeling that all of that's probably not so unusual. Probably Janine and Heather could speak to this from their work with different districts and teachers around the state. But I think the first challenge is trying to make sure that we can help teachers know how to teach statistics.
Mm-hmm.
And it can be uncomfortable at first because we're so used to teaching math from just here's a formula and we can crunch out things and calculate. And if we allow teachers to teach that way, that's in their wheelhouse.
Right.
It's the explanation and getting the concept and knowing that really it's a little less about the calculating and a little more about the interpretation. And notice the 2-part questions I showed you. Neither of them really asked for calculation. It was really just understanding concepts. So I have a couple suggestions. One is, when teachers are working, they need a good curriculum, essentially. They need a resource that they can go to. At Lyons Township High School, recognizing that we were going to have the same problem for our Algebra 1 and our Algebra 2 courses, I worked with a great teacher who teaches Algebra 1 quite a lot at our South Campus. Her name is Tina Dunn, and the two of us worked together and spent several weeks over the summer basically writing a math curriculum, and included the notes, the assessments, all the activities, all the homework assignments for the whole unit. And then offered a training session not only to our Algebra 1 teachers, but to all of our feeder schools, all the middle school Algebra 1 teachers. We invited them in, shared all the resources, and walked them through the materials. And then I did the same thing with Algebra 2 and created materials. It's not an easy thing to do, particularly if you do not feel comfortable right from the get-go. So then my suggestion is borrow from places where there are great resources. On the Illinois Stats website, there are activities there from probably just about every standard, and certainly people can go there and use them. When I shared those activities, some of them I created, but some of them actually came from really wonderful statistics educators around the country who agreed to share their information so that they could be used by Illinois teachers. So there are some wonderful, wonderful activities there. I have to say, if I were a 6th grade teacher or 7th grade or 8th grade, and while I've taught high school, I just recently retired. So if I went out and could get a job at a middle school and knew that I was going to have to teach statistics, what I would probably do is ask my administrators if I could go to illustrative mathematics and actually use their stats unit that they have. In fact, there's part of me that would really love to try to teach their whole course and use it. But what I do know is they've had some really wonderful statistics educators helping to create their statistics unit. It is very problem-based. It is very guided. There's lots of information to help teachers know what to say and how to run the lesson. There are openers, there are closers, there are activities that allow students to discover the concepts. And so for teachers who are struggling to know how to teach it, that might be a great route to go. And I would say the same thing about Engage New York. I know that Roxy Peck, who is just this amazing statistics educator, was actually involved in, I believe, in both the illustrative mathematics curriculum and the Engage New York statistics curriculum. But the Engage New York curriculum also is fantastic. And both of them are available for free. So if money is an issue and you don't want to go out and shell out money for a statistical resource, and I may have just lost my PowerPoint there.
And I'm just going to share real quick while you're looking for that. We are one
thank you.
out of time, but two, Illinois State Board of Education and Illinois State University do not endorse any specific curriculum or product. However, using things as resources is great, and we appreciate that Julie provided not only resources, but free resources that are available.
Yeah.
And essentially, a quick thing to share.
Yeah, the only thing I would add is that it's that the nice thing about that is it's free, but if you enjoy their curriculum, then they do have opportunities to buy it in published form and in textbook. I would start off and just try it as a pilot and try it free. And once teachers are comfortable, they could then tweak it and try things from the Illinois Stats website or from NCTM. And thank you guys. I appreciate getting to share things. If I can ever be of help, please feel free to email me. It's just jabrunson@gmail.com.
And I just want to thank you so much for coming. I did just post in the chat window our post survey. We'll also send an email with it once the recording has been posted up. But if you have a chance, please let us know any feedback that you have, and we will use it when we plan future IL Math Comms. So thanks everyone so much, and have a great night. Thank you.